Hi everyone, this is Mrs. Bokerman. Today I'm going to teach you the factoring where it's a little bit mixed. Okay, so to get started, this video is going to be kind of long just because there's so many options and things we need to talk about because this is really the heart of factoring. So the first thing I want you to notice is we could multiply these things out, and these look very similar except for one key difference. The only difference is this one says 2x minus 5, and this is an x minus 2, and this one says 2x plus 5, and that is x minus 2. So those are the same. So without spending too much time, if I were to multiply these two things out, if I multiply out the first one, I get 2x squared minus 4x, then go back and multiply this negative 5x, and a negative 5 times a negative 2 becomes a positive 10. And then once I combine like terms, I would get 2x squared minus 9 plus 10. So how would it change if I just simply change this negative right here to a positive? Well, I would still end up with 2x squared. I would still end up with a minus 4, but then I would have a positive 5, and more importantly, 5 times negative 2 is negative 10. So a big difference here. At the end of this one is a positive 10, and at the end of this one, it's a negative 10. Okay? And I want you to know that these two symbols are the same. These are different. So what I want you to gather from this is the only time that your last term is going to be negative is when you have to have opposites. One has to be positive and one has to be negative. And that's when factoring gets a little bit trickier. Okay, so let's talk about this. This is a really good page for you to take a screenshot of, to write it down, to pause the video, put this somewhere. Okay, because this will help you. All right, when you're factoring, you always want to look at the last term, your C value. If your C value is positive, that means you're going to have the same symbols. Okay, that means the very first thing we taught you is positive, positive. Okay, and that's if everything's positive, your symbols are all positive. If the last term is positive, but the middle is negative, then they're both negative, negative, negative. Okay, it's when the C value term is negative at the end, that's when you have to have one of your factors being positive and one being negative. And it totally does matter which one is which. And it can get kind of tricky to figure out which one is which. And to figure out which one is which, you then look at the B value in the middle. But as soon as you get a negative C, you have to have opposite signs. If it's a positive C, then your symbols are the same. They're either both plus plus or they're both minus minus. Okay, so hopefully that helps a little bit. So let's get started. I'm going to do kind of 5 examples with you just to kind of get you going. So notice C is negative. Okay, very first step of every factoring problem is to see if there's a GCF. But I see a 5 and a 19, so I know there's nothing that they have in common. So I go right away to factoring. So I look at the first term. How can I get 5? That is a 5x and an x. Okay. Then if I'm looking at 4, what are the ways that I could get 4? I have 2 options. I have 2 and 2, or I have 1 and 4. So naturally, I always start with 2 and 2, and then I check it. Notice I'm not putting symbols here because I don't know what they are. One has to be positive, one has to be negative, and it is going to make a difference. Okay, so if I put 2 and 2, then I check it. I check the big loop. 5 times 2 would be 10. I check the inner loop. 2 times x would be 2x. And even with one being positive and one being negative, 10 and 2, there's no way that I could make 19 out of that. Okay? So if I were to switch the 2 and the 2, I would actually get the same answer because 2 and 2 is actually the same number. So instead of trying 2 and 2 again, I'm going to switch and try 1 and 4. Okay, so I'm going to put the 4 here and the 1 here, and I'm going to check it. So then 5 times 1 would be 5, and 4 times 1 would be 4, and there's no way, again, with a 5 and a 4 that I can make a 19. So naturally, I'm going to switch the 1 and the 4. Okay, so then here is where I get 5 times 4 is actually 20, and 1 times x is actually 1x. And if I had a 20 and a 1, I totally could get 19 if I made this 1 negative and I made this 20 positive. So that's how you kind of figure out your symbols. 20 came from 5 times 4. So this is where I'm going to put the plus, and this is where I'm going to put the minus. If you put it the other way, you would actually get a negative 19 instead of a positive. Okay, so that is the right answer, and I'm done. Let's try another one. All right, so last term is negative. I first check, can I make this smaller? But I have a 2, a 13, and a 24, so no GCF. So you can see my kind of list over here. I automatically jumped because 24 also has a lot of different combinations. 1 and 24, 2 and 12, 3 and 8, 4 and 6. Okay, so let's start at the beginning. C is negative, so I'm going to have a plus and a minus. This is 2, so the only way to get 2 is to do 2 and 1. That has to be true, so that's pretty good. Then I go to 24, and this is where I'm randomly guessing. I generally like to try 3 and 8 and 4 and 6 first. Those are kind of my go-tos, and it actually doesn't matter which one you try first. Okay, so let's try 4 and 6. Okay, so if you try 4 and 6, you would get a 4x, and 2 times 6 would be 12. 12 and 4 seems like it could get to 13, but there's no way that would happen. 12 and 4 wouldn't work, okay? So here's another little secret that hopefully you're ready for, okay? And this kind of helps you, especially when you have a lot of different factors. If this goes over your head, don't worry, you can still check them. Just I can tell you right away that this is not going to work. You never, ever, ever want to put factors that are the same inside the same parentheses. So what I mean is I know that this is not going to work because there's no way that I could put a 2 and a 4 in the same parentheses. Because if I did, that implies a GCF where I would have taken out a 2 and those would be both divisible by 2. Since the original problem does not have a GCF, that means this can never happen. Okay. Similarly, I couldn't put a 6 here because 2 and 6, they also have a 2 in common. So I know right away that 4 and 6 are never going to work because I can't put a 4 next to a 2 and I can't put a 6 next to a 2. Okay. Another similar idea is if you have like a 3x in a parentheses, you could never put a 6. You could never put a 9. You could never put a 12. You could never put a 3 because that implies a GCF. Okay, so you can never put a number that has a GCF with it inside the same parentheses. That will maybe help you get through this list a lot faster. Okay, they're too similar and it automatically won't work. Okay, so since I can't put a 4 here and I can't put a 6 here inside with that 2, I'm going to jump to 3 and 8. Now, I hope you're thinking, I also can't put an 8 here because 2 and 8 would have a 2 in common. So I'm going to naturally try the 3 first. Okay, so I could check it. If I put a 3 here, then if I multiply, 2 times 8 would be 16, and 3 times x would be 3x, and that could totally make negative 13 if this was negative and this was positive. A negative 16, the bigger thing has to be negative for it to be negative 13. So 16 came from the 2 times the 8, so this is negative and this is positive, and that's exactly what I got as my answer. Okay, there's all these little tricks to help you get through factoring problems faster. All right, 12, 14, 10. First thing you do is check to see if there's a GCF, and there is one, 12, 14, and 10. You definitely want to make your number smaller if you can. So I'm going to take out a 2. So I'm going to divide all that by 2. 12 divided by 2 is 6. 14 divided by 2 is 7. 10 divided by 2 is 5. Okay, so this is what I have. Now, the 2 is just going to go along for the ride, and now I'm factoring just this inside. So now I'm looking at 6. How could I get 6? I would try 3 and 2, and it doesn't matter if you put 2 and then 3. That doesn't matter, okay? And now I'm looking at 5. My last term is negative, so that means I'm going to have one positive and one negative, and I got to figure out which one is which. But 5 is actually a nice number because there's only one way to get 5. It's either 5 and 1 or 1 and 5. Okay, so I'm going to randomly guess. Notice this 2 is just coming along for the ride on the way. I'm going to guess and I'm put a 1 here and a 5 here. So then if I check, 3 times 5 is 15, and 1 times 2 is 7, and I'm trying to get 7. So it worked. Okay. Oh, wait, 15 and 2 do not make 7. Sorry, I was thinking 5 and 2 did. 15 and 2, there's no way that that would make 7. So the easiest thing to do is to switch the 5 and the 1, and that's what I did here. So this would give me 3, and 5 times 2 would give me 10, and I want to make a positive 7. So that means the 10 has to be positive, and the 3 has to be negative. So the 3 came from the 3 times 1, so this is negative, and the 5 times 10, that would have to be positive. And again, you could just multiply this out to double check that it works, but here's the correct answer. All right, number 4. I got 2 more for you. This one and one more. Again, notice there's a cube. That automatically means that there's a GCF. You only factor with these guess and checkers when it's a trinomial and that it's x squared, okay? So I'm going to check. I have a 2, a 13, and a 6. So I actually can't take out a number, but I can take out an x. So everything is going to get divided by x. So each one has one less x. And now you'll notice you have your ax squared plus bx plus c. The biggest thing I want to point out is, anyone notice that it's a plus plus? That majorly helps us because we don't have a plus minus situation going on. Okay. We have everything has to be positive. So I can automatically jump to, hey, how can I get 2x? It has to be 2x plus and it has to be x plus. Okay. Again, if this is positive, then your symbols are the same. Then you look at your middle term. Okay. Since this is positive, they're both plus. If this had been negative, then they would both be minus. Okay, it's only when this last term is negative that you have to have a plus and a minus. And that's when I normally leave the symbols out until I can figure it out. All right, so x came down for along the ride because that's our GCF. I'm trying to get 6, so I'm probably going to use 3 and a 2. I am not going to put a 2 here because that would imply GCF. So the natural thing to try is to put the 2 here, which is what I did. And then I check. So this is going to be 4, and that's going to be 3, but I'm trying to make 13, so that's not even close. I know not to switch the 2 and the 3 because that's not going to work. So there's one other way to get 6, and that's 6 and 1. Okay, so I also know I'm not going to put the 6 here next to the 2 because that would be 2 and 6 have a 2 in common. So I'm going to try the 6 over here. So 2 times 6 is 12. 1 and x is 13, and that, if they're both positive, makes 13. So that's the correct answer. All right, last one. 4, 4, and negative 5. Notice this is negative, so we have one of each, okay? How can I get 4? Well, I'm going to try 2 and 2. That's the natural way to do it. And how can I get 35? You're probably thinking 5 times 7. That's the most common way to do that. Okay, so then I would check it. 2 times 7 is 14, and 5 times 2 is 10, and I'm trying to make a negative 4x. So that would work if negative 14 plus 10. So negative 14 came from the 2 times 7, so this is negative, and 5 times 2 is 10. This is positive, and I happen to get it on the first try, which sometimes works out. Okay, so the best thing that you can do is practice, practice, practice. Just remember, if it's the last term is negative, you have to have one of each. If it's this positive, then it's the same symbols, plus, plus, or minus, minus, okay? But you have to practice, practice, practice. All right? Best of luck. Bye.